taking notes, okay? So yesterday when we talked about circles, we defined a circle. It is the set of points that is equal distance from the center, from a center. So basically, if you look at a circle, it's all these points that are equally distant from a center point. That equal distance is called the radius. That's the definition of a radius. We also talked about the fact that a diameter is the whole way across. A diameter goes through. Its endpoints are on the circle, which makes it a chord, but it's a special chord that goes through the center, the center point. So this is your radius, just part of it is your radius. Okay, this is the diameter. We also defined a chord as any line segment that connects, has its endpoints on the circle. So a chord is a line segment in the circle with its endpoints on the circle. So you can have an infinite number of these inside the circle because they go from into them, okay? If you have a chord that is bisected by the diameter, then we know that those are perpendicular. So if it's bisected, so if a chord is bisected by the diameter, then the lines are perpendicular. Okay? If the lines are perpendicular, then the chord is bisected. Okay, so that's basically some of the lines. Those are the lines inside of a circle. So we're defining some lines. We have radii, that's a line. We have diameter, which is a line or a chord through the center. And we have chords, which are from one point on the circle to another point on the circle. And those are the things inside a circle. Then we have the lines that are outside a circle. And we have what's called a tangent line, which hits, it is perpendicular, so it hits at one point, hits or touches the circle at one point only, and it is perpendicular to one radii. Okay, so basically that's just saying that if you have a line that's coming through, for it to be tangent and it can only hit in one spot, when it does hit in that one spot, there is a radius that it's perpendicular to. Okay, so those are all the lines right now that we're looking at in circles. That was 12.1 and 12.2, was all the different things about the lines inside and outside that we name them. Okay. Today what we're going to go into is the angles in a circle or outside, actually mostly inside the circle today. Today we're gonna look at angles inside the circle and the different names of them and some of the different measures or way to find their measures. Okay, so this is from yesterday. It's all about the lines in a circle and outside of the circle that are given specific names. Okay, and those are the things that you can get from these. Lots of right angle things, bisecting, that kind of stuff. So now we're going to go into the angles that are in a circle and what they're called. Okay. So the first thing, did I not let you have time enough? We have the center of our circle. So here's our circle. Okay. First thing, what I want to know, if I were to go from here all the way around like that, how many degrees are in a circle?
360.
Yes. A circle is 360 degrees, because if you go around, just think, I don't know who does skiing or who does anything like that, but if you do a 360 on a skateboard or something, you are turning completely around and then going back the same way that you were going before. So you're doing a whole circle, that's called a 360. Okay, so that's what it's called. Okay, that's because a circle is 360 degrees. Okay, so the first angle that we talk about is, this is, okay, so let's say I have this, A, B, C, okay? There are actually two angles here. Does everybody see that? There are actually two angles. We have this angle here, that's one angle, but then we actually, if I called it angle ABC, we actually have this angle also. Okay, so to distinguish between those two, we give them two different names. Okay, so because angle ABC could be the littler angle, or it could be the bigger angle. Okay, so what we call, let's start with the little angle. The little angle, the angle less than 180 degrees is called the central angle. It's called the central angle. Now notice, this is when we are talking the central angle has its vertex in the center. Kind of makes sense. A central angle has its vertex in the center. So the vertex is in the center, or at the center, I should say. Okay, so that's called the central angle. That's usually the one we are talking about the most, is the central angle. It's also called, this is actually called the minor arc, because this arc right here is smaller than this arc here. Okay, but we'll come into that in just a minute. Okay. The other angle, this angle out here, is called a reflex angle. Is the other angle formed in the center with a central angle. So it's just really defined as the other angle that you have along with the central angle. Okay? So it's just so we know how to determine which one are we talking about. If I say I'm talking about the central angle ABC, then you know it's the one that's less than 180. So if this one's always less than 180, what is this true about B? What angle is the reflex angle? What's the degrees of a reflex angle?
Greater than 180?
Yeah, it's gonna be greater than 180 because the one up here is gonna be less than 180. So this is going to be greater than 180, okay?
Taking slices out of the pie.
Mhm.
Okay, yeah, it's 2 slices of pie. Somebody gets a big piece, somebody gets a small piece.
Really big piece.
Yeah, that's a big piece of pie. If you're eating that much. Okay, but those are the 2 different angles that you can have inside. Okay. Now, I'm in the wrong section. Oh yeah, arcs. Okay. Central angle. Okay, so basically an arc, so instead of an angle, we also have arcs, okay? An arc is formed basically by an angle, okay? So if we're looking at this, when I am talking about an arc is the actual amount that's this space right here. It's the arched part between A and C. That's an arc, okay? So the arc AC, which is written this way, arc AC. We always refer to the arc as the shortest or the central angle measure, okay? So if you're looking at arc AC, it is this angle, or this arc, not this one, not the bigger reflex. It's always the smaller one that we're looking at, okay? If I wanted to refer to this, I would actually have to put another spot or another dot on it, another point, and if I said O, then I could refer to the bigger one as arc. So this, come on. I love pens sometimes. Arc AOC, okay? That's the other arc that you have, okay? So when we're looking at these, we have to know that these 2 arcs, they're gonna add up because we have a major arc and a minor arc. They're gonna add up to be how much?
360.
360. So an arc's measure, the measure of an arc, is determined by its central angle. So the measure of an arc, okay, is determined by its central angle, or the angle formed, I guess it's not just the central angle, but so it's by this, I shouldn't call it the central angle, the central or reflex angle. Okay, so it's whatever angle is here that you have, that's the measure of the arc. So the arc is just the length around the circumference measured in degrees. Okay, so that's what arcs are called. Okay, so in circles, if I have a chord that goes from here to here, and another chord that's the same length that goes from here to here, okay,
Looks like Jupiter.
it looks like Jupiter. So then if we were to look at those, this is just to kind of give you what finds out, okay? So if I were to look at two equal, these are equal to each other, okay? So if I were to take this center and I go out to here, out to here, out to here, out to here, what do I know about these two angles right there? This is actually a straight line. Okay.
They're the same.
They're the same, okay? So if the arcs are the same, then the angles are the same. So if two arcs are the same, then, I mean, two chords are the same, then their arcs are the same. Does that make sense? So because these two are the same, then these are gonna be the same, which makes the arcs the same. So if I call this A, B, C, D, since AB is equal to CD, we'll call this angle E, then angle AEB is equal to angle, let's see, it doesn't matter, DEC. Therefore, the measure of arc AB is equal to the measure of arc DC. Okay? Because this arc will equal that arc because these are the same, their angles are the same. And remember, the measure of the arcs are defined by their central angles. So if the angles are the same, then the arcs are the same. Same thing. If you know that these two arcs are equal, then you know that their two central angles or their two angles are equal. Goes backwards. Okay? So that's something you can tell about that. So those are some of the things that we can come up with looking at arcs. So we've defined now angles inside that start at the center. So far we've only talked about angles that start at the center. Okay? They are called central angles or reflex angles. We have defined what arcs are. Arcs are basically these arcs right here. They look like an arch, so they're an arc. Okay? An arc is written with a arched sign over it. We name it with two letters if it's the central angle. We name it with three angles if it's the reflex, or three letters if it's the reflex arch. Okay? So then we decided that chords, if we make angles through them, if the chords are equal, then their arcs are equal. So that's something we can find now, is if we know those, then you can find that. Yes?
So those little cross things, that means they're bisected by the diameter.
No, this means they are equal.
Equal length?
Yeah.
Oh.
So we started with that AB is equal to CD.
Oh.
Okay? Then we said because those two are equal, we know these vertical angles are equal. Because remember, the sides across from, they're always the same. So we know that from all of our sines and cosines and tangents. The ratio is going to be the same. Yes?
So, if two arcs are the same, does that mean they're parallel?
It doesn't necessarily mean they're
or
parallel.
perpendicular?
No, it doesn't mean that. This is just showing you why they're the same. But there could be an arc here, as long as it's the same length as this one, they would also be the same, like if the chord is the same distance. So we could have another chord that's drawn like this, or two chords. We could have a chord drawn here and a chord drawn here. As long as they're the same, then their arcs are the same. Or that means basically their angles at the center are the same. So all of those things. So as long as they are the same length, when I go inside then to the center, which you know I'm not a good drawer, so then from here to here, so as long as these two arcs are the same, then these two chords are the same, then this arc is going to be equal to this arc, this angle is gonna equal that angle. Okay, so it can be overlapping, it does not have to be parallel. I drew this for ease of seeing it, but no, it can be any chords that are the same length. Okay. Now, using that, and using, no, we have to talk about something else, yeah. Okay. So, we're going to talk now about inscribed angles. Inscribed angles. Okay. These are not central angles. They do not begin at the center of the circle. Okay. So an inscribed circle has its vertex on the outer edge of the circle. So an inscribed angle has its vertex inside or on the circle. That's what a vertex angle. So if I'm looking at this, and here's my center, and if I put something here, and I go out like this, and I go out like this, okay, that is an inscribed angle, because here it goes A, B, C. Notice B, its vertex, is on the circle. It's not in the center. Difference between a central angle and an inscribed is that an inscribed has its vertex on the circle, not on the center. Okay, so that's the difference. Okay. What's very interesting, I'm not going to go through the proof for it, but what happens is basically you're getting similar triangles. Kind of out of here you can get similar triangles. Okay. What happens, or actually we're dilating we're making it thinner. Okay, it's a dilation of it. Okay. So what happens is if I know the measure of this, okay, so if I know the measure of the central angle, so let's say it is 60 degrees. The inscribed angle is exactly half of that central angle. Okay, so if you have a central angle that goes through the same points, it has to go through the same points as your inscribed angle, then this is half of the central angle, so this would be 30 degrees. Okay, so an inscribed angle the measure, okay, let me start all over again. I got that all screwed up. The measure of an inscribed angle is 1/2 of the enclosed arc, which really means it's 1/2 of the central angle of that arc, Okay, so it's really defined by the arc, but we know that the arcs are measured by the central angles. So the central angle is really what determines how big this one is. Because once I know that this is a 60-degree arc, I take half of that for the inscribed triangle, or inscribed angle. Okay. Or if you just know this is the central angle that goes through that arc is 60, then the inscribed one is half of it, which is 30. Okay. So if that's true, I have a question for you. Oh, yeah. Oh, Terry can't draw. Okay. What is the measure of that angle? First, let's figure out what is the measure of that arc that it goes through. So here's my arc. Okay, right? It goes from here to here. What is that measure? Yes.
Wait, so is that mystery angle just like 90 degrees because
Why?
the diameter is 180, and so
That's correct.
half the diameter is
Yes, because this arc right here, because it's a diameter, right? That angle is 180 degrees. It's a straight angle. It's not really an angle, but it is an angle because it's a straight line. A straight line is defined as 180 degrees. So this one is going to be 90 degrees. So anything that I put down here that goes through the diameter, has endpoints on the diameter, anything I inscribe with the diameter endpoints as where it goes through your circle is going to be 90 degrees. It doesn't matter what. So how they say that is, I have to see how they say that. Oops, we're not up to that one yet. Those are different angles. Oh, an angle inscribed in a semicircle is always a 90-degree angle. Okay? So let's think about what that says. This is what it says. An angle inscribed in a semicircle is always 90 degrees. What is a semicircle?
180 degree angle.
What's a semicircle? Yeah,
Half a
it's
circle.
just half a circle, okay? A semicircle is half a circle. So if I have exactly 1/2 of a circle, that does not look exactly like 1/2 of a circle, but that's okay because I drew it, okay? If you have that, or if you can see, do you see that this is that right there is a semicircle? Okay, so anything that's inscribed in that is going to be 90 degrees. It doesn't matter where I draw it, as long as it's inscribed, it's going to be 90 degrees. Okay, and so that's something we can look at. Okay, it's something that they use a lot. Okay, so it really comes from the fact that the measure of an inscribed angle is half of the enclosed arc. Okay, but here my enclosed arc is 180, so then that must mean it's 90, and then we give the word semicircle to easily describe that instead of saying the diameter and all that stuff. We say the semicircle, and that's how we describe that. Okay? So that's really some of the different angles that are inside the triangle, or the circle. Okay, so those are some of the things that go with the angles. You have reflex angles, you have central angles, you have inscribed angles. We've defined what an arc means. We've defined how to label an arc. We've defined that an angle and its arc have a central angle and its arc have the same measure. Same thing with the reflex angle and its arc. They have the same angle, or measure, excuse me. We've talked about inscribed. Inscribed are exactly half of the central angle itself. So if you take an inscribed angle, you're gonna see that it's exactly half of that. And so that's the things that we have talked about. And then based on that, anything that's inscribed in a semicircle is going to be 90 degrees. Okay, and so it's a nice way, nice easy way actually, that they could draw 90-degree angles. You could draw a circle, and then you could just draw any point out to the ends, and you have a perfect 90-degree angle. So back when they could draw, so instead of trying to figure out how do I draw a 90-degree angle and measure it and see if it makes a Pythagorean theorem and all that, what they could do is they could draw a circle with their rock and their string, okay? Take something from any point on that semicircle out to the diameter, and they would get a 90-degree angle, perfect 90-degree angle. And so it was a way that people used to measure 90-degree angles and draw exactly a 90-degree angle before we had a lot of other material. Okay, so they knew that was a perfect 90-degree angle. Then they could connect it, and so they could make that's how they came up with Pythagorean triples, because they could draw them and see what this line was. Because you knew the diameter then, so they'd take a diameter and they'd say, okay, let's draw different lengths and see if we can ever get something that's all whole numbers. Okay, and that's also how they discovered that a lot of times in Pythagorean's theorem, one side is an irrational number that goes on forever and ever and ever. So they played with those things a lot because they could do it very easily. They didn't have to have complicated machinery or anything. They could just draw those circles using their rock and their string, or whatever their post and their string, a tree and a string. I mean, all those kinds, they were ingenious and using stuff. Then they could measure things, and so they learned how to figure out all sorts of things about right triangles, basically using a circle, because they found out that inside this semicircle you always have a right triangle if it's inscribed inside there. And so that's how they used it. We can still use it today if you want to come up with some perfect 90-degree angle. If you don't have something that measures your angles, but even with a compass, that's basically kind of what you're doing, is you're striking an arc of 90 degrees, and so that's what you're actually doing, and so that gives you, or an arc of 180 degrees is what you're actually striking. It's measured differently on your compass, but, or on your protractor, sorry, wrong word, protractor. Any questions on that? Okay, so we're gonna do a couple problems. Let's do a couple problems at your desk.
Is that 10-3 and 10 or 12?
That is 12-3 and 12-4. I covered both. We're gonna cover some more angles when we come back from break. Some more angles that relate to a circle. These are gonna be more the outside angles. So today we really focused on the inside angles, which are really just reflex, central, and inscribe. But then we learned some things about the arcs, defined what an arc is, defined what the measure of an arc is, defined if two chords are the same length, then you know that they have the same arc, okay? Or their central angle is the same, okay? So, I'm gonna put this on, turn this off now.